The Meteoric Era, the Volcanic Age, the primitive planetary atmosphere. Throughout these early times, the space regions of the solar system were swarming with small disruptive and condensation bodies, and in the absence of a protective combustion atmosphere, such space bodies crashed directly on the surface of Urantia. These incessant impacts kept the surface of the planet more or less heated, and this, together with the increased action of gravity as the sphere grew larger, began to set in operation those influences which gradually caused the heavier elements, such as iron, to settle more and more toward the center of the planet. 2 billion years ago, the Earth began decidedly to gain on the Moon. Always had the planet been larger than its satellite, but there was not so much difference in size until about this time, when enormous space bodies were captured by the Earth. Urantia was then about 1/5 its present size and had become large enough to hold the primitive atmosphere which had begun to appear as a result of the internal elemental contest between the heated interior and the cooling crust. Definite volcanic action dates from these times. The internal heat of the Earth continued to be augmented by the deeper and deeper burial of the radioactive or heavier elements brought in from space by the meteors. The study of these radioactive elements will reveal that Urantia is more than 1 billion years old on its surface. The radium clock is your most reliable timepiece for making scientific estimates of the age of the planet, but all such estimates are too short because the radioactive materials open to your scrutiny are all derived from the Earth's surface and hence represent Urantia's comparatively recent acquirements of these elements. 1,500,000,000 years ago, the Earth was 2/3 its present size, while the Moon was nearing its present mass. Earth's rapid gain over the Moon in size enabled it to begin the slow robbery of the little atmosphere which its satellite originally had. Volcanic action is now at its height. The whole Earth is a veritable fiery inferno, the surface resembling its earlier molten state before the heavier metals gravitated toward the center. This is the volcanic age. Nevertheless, a crust, consisting chiefly of the comparatively lighter granite, is gradually forming. The stage is being set for a planet which can someday support life. The primitive planetary atmosphere is slowly evolving, now containing some water vapor, carbon monoxide, carbon dioxide, and hydrogen chloride. But there is little or no free nitrogen or free oxygen. The atmosphere of a world in the volcanic age presents a queer spectacle. In addition to the gases enumerated, it is heavily charged with numerous volcanic gases, and as the air belt matures, with the combustion products of the heavy meteoric showers which are constantly hurtling in upon the planetary surface. Such meteoric combustion keeps the atmospheric oxygen very nearly exhausted, and the rate of meteoric bombardment is still tremendous. Presently, the atmosphere became more settled and cooled sufficiently to start precipitation of rain on the hot rocky surface of the planet. For thousands of years, Urantia was enveloped in one vast and continuous blanket of steam, and during these ages the sun never shone upon the Earth's surface. Much of the carbon of the atmosphere was abstracted to form the carbonates of the various metals which abounded in the superficial layers of the planet. Later on, much greater quantities of these carbon gases were consumed by the early and prolific plant life. Even in the later periods, the continuing lava flows and the incoming meteors kept the oxygen of the air almost completely used up. Even the early deposits of the soon-appearing primitive ocean contained no colored stones or shales. And for a long time after this ocean appeared, there was virtually no free oxygen in the atmosphere. And it did not appear insignificant quantities until it was later generated by the seaweeds and other forms of vegetable life. The primitive planetary atmosphere of the volcanic age affords little protection against the collisional impacts of the meteoric swarms. Millions upon millions of meteors are able to penetrate such an air belt to smash against the planetary crust as solid bodies. But as time passes, fewer and fewer prove large enough to resist the ever stronger friction shield of the oxygen-enriching atmosphere of the later eras.